Still talking about operations with surds, we now move on to multiplying surds, having considered addition and subtraction of like surds in the last video. Multiplying surds is now what we look at. Multiplying surds, surds are irrational roots such as root 2, root 3, root 5 that cannot be simplified into whole numbers. We already know that. Then in this lesson, we study multiplying simple surds, multiplying mixed surds, expanding two brackets containing surds, and the difference of squares, identity. So let's go straight for that. Multiplying simple surds. So we have a simple rule that the square root of a times the square root of b is equal to square root of a times b. And this rule works because square roots follow exponent laws. For instance, square root of a is a raised power half. Therefore, a raised power square root of a times square root of b is like a raised power half times b raised power half. And then we know from the rule of sort that if two numbers are raised to the same power, you can so the product of those you multiply those numbers, right? They can then multiply the two numbers raised to the same power. So a raised power half times b raised power half is the same thing as a times b raised power half, which is square root of ab. So that's why that works. And then you have an example, square root of 3 times square root of 5. You just multiply inside the root. So you have square root of 15. So the final answer is root 15. Root 15 cannot be simplified further because there's no square roots inside of 15. You can't factorize the square root out of 15. So that's the answer. You leave it like that. Then we go on to the next one, which is a little bit different. Square root of 4 times square root of 7. So that's square root of 4 times square root of 7. That's root 28. And then, of course, square root of 4 is 2. So you can have 2 root 7. Final answer is 2 root 7. Then instead of going this way, you could actually go straight and, not worry about multiplying first. So you have square root of 4 times square root of 7. So instead of stressing out to do root 28, you already know that square root of 4 is 2. And square root of 7 is just square root of 7 because it is irrational. You cannot express it as an integer like for the square root of 4. So 2 root 7 straight and you get your result. Example 3, you have 6 times 10. Okay, in this case, you cannot factorize the square root out of 6. You cannot factorize the square root out of 10. So the first thing you can do is multiply 6 and 10. So square root of 6 times square root of 10 is square root of 6 times 10, which is square root of 60. And from 60 now, though you couldn't do it separately, but now from 60 you can factorize the square root, which is 4. So root 60 is square root of 4 times 15. Square root of 2 is 2. I mean, square root of 4 is 2, and then you have root 15, which cannot be simplified further. So root 6 times root 10 is the same thing as 2 roots 15. So sometimes you're not able to get the square root from the individual numbers, but when you put them together, the square root jumps out at you. So that's talking about multiplying simple sorts. What about multiplying mixed sorts? So a mixed sort has a number outside the root. For instance, you have 3 root 2 and 5 root 7. Unlike addition and subtraction, you can actually multiply any type of sort, no matter what they don't have to be like sorts for you to multiply. You can multiply any two sorts, whether they are like or unlike, whether they are mixed or not mixed. So the simple rule here is that if you have a root m multiplied by b root n, you multiply the coefficients separately and multiply the surds separately. And after multiplying the surd, like, so in this case, a times b root m times n. So after multiplying m times n, if you now can't, you now have to reduce it to the simplest form. Like if you can factor out a perfect square apart from 1, then you have to go for that. So an example to take that home, you have 3 root 2 times 4 root 5. So multiply the coefficient, that's 3 times 4, which is 12. Multiply the surds, that's root 5 times root 5, root 2 times root 5, that's root 10. Put it together, you have 12 root 10. 10 cannot be simplified further than this because there's no perfect square factor that can be factored out of 10 apart from 1. Okay, so example 2 now. For example 2, you have 2 root 3 times 5 root 6. So if you step 1, multiply 2 times 5, you get 10. Step 2, root 3 times root 6, you get 18. So, but then 18 can still be simplified. So you have root 18 is 3 root 2. So finally, it means we have 2 root 3 times 3 root 2. That's step 4 now. Okay. Uh, so you have 3 root 2. And then at the end of the day, you have 30 root 2. Okay, let me do it on the worksheet because I feel that the way this one is broken down it can be a bit confusing. Let me just go straight. 2 root 3, 5 root 6. Okay? 2 root 3, 5 root 6. Okay, so we're talking about 2 root 3 times 5 root 6. So that's multiply 2 times 3 then multiply 3 times 6 in the under the square root. So this is 6 root 18. And from 18, we can get a perfect square, which is 9. That is 6 root 9 times 2. So square root of 9 is 3. So we have 6 times 3 root 2. So 6 times 3 is 18 and then root 2. And that's what we have like that. So in this case now, we go on. Oh, what's wrong here? This is 10 root 18. Okay, I guess something is wrong, really. So this is root 3 times root 6, that's root 18. And root 18 is 3 root 2. But here we have, okay, maybe something is wrong with what I did. Oh, this is 5 actually. So it's my fault. So this is 2 times 5 actually. And 2 times 5 is 10. Okay, so this is now 10, not 3. So this is 10 times 3. So 10 times 3 is 30. Okay, so let's be careful. That's 30 root 2 there. So example 3. For example, 3, now we have 4 root 5 times 3 root 15. So again, 4 times 3 is 12. Root 15 times root 5 times root 15 is root 75. And a perfect square can be factored out of 75, which is 25. So the square root of 25 is 5. So you have 5 root 3. So 5 root 3 now times 12. 5 root 3 times 12, that's 12 times 5 root 3, which is 60 root 3, and that is 60 root 3 answer. Okay. Um, yeah. So another thing you want to do is you want to expand brackets with surds. That's another approach. That's another thing we can encounter rather. We use the distributive rule, FOIL method, that is A times, so A times C plus A times D plus B times C plus B times D. That's exactly what we have it. That's the FOIL method. So you have A times C, AC, A times D, AD, B. Okay, or maybe let's take the sign. Plus A times C, that's plus AC, plus A times plus D, that's plus AD, plus B times plus C, that's plus BC, plus B times plus D, that's plus BD, like that. So just like we do in algebra, right? So here we have 2 root 5. Okay, I think it's getting too big. So you have 2 root 2 plus 3 into root 5 plus 4. So first you have root 2 times root 5. That's root 10. Then next, you have root 2 times 4. That's 4 root 2. Then 3 times root 5. You have 3 root 5. Then 3 times 4 is 12. Then you combine all of them. You have root 10 plus 4 root 2 plus 3 root 5 plus 12. And none of them can be simplified further, so you have to leave it this way. But then let me go back. Let me do it on the worksheet. Root 2 plus 3, root 5 plus 4. Okay? Root 2 plus 3, root 5 plus 4. Root 2 plus 3 multiplied by root 5 plus 4. So using the FOIL method, so it means you have root 5 times root 5, I mean root 2 times root 5. So this is this and this. Then next, plus root 2, this root 2 now times root 5. Or okay, I think I'm jumping. Let me go gradually. So we can take root 2, right? So take root 2 multiply by root 5 plus 4, then take 3 and multiply by root 5 plus 4. I think this is better. So root 2 multiplies everything first, then root 3 multiplies everything like this. So I think this is better. So we see the product straight up. So we can move on now. So this is, so you can expand root 2 times root 5, that's root 10. Root 2 times 4, that's 4 root 2. 3 times root 5, that's 3 root 5. Then 3 times 4 is 12. So we go like that. So we can simplify. Okay, there's nothing to simplify. We just have root 10 plus 4 root 2 plus 3 root 5 plus 12. So there's nothing else we can do to this. So this is the result. Now, we can't simplify further because all the numbers are unlike, you know, all the sorts are unlike, and we only have 12 there as a whole number. Okay, so we have 2 plus root 3 into 1 plus root 3. So that's 2 times 1, 2. 2 times root 3, that's 2 root 3. Root 3 times 1, that's root 3. Root 3 times root 3 is root 9, which is 3 actually. So if you put everything together, you have 2 plus 2 root 3 plus root 3 plus 3. That's 2 plus 3 is 5. 2 root 3 plus root 3 is 3 root 3. And that's the result. So let me do it on the worksheet. 2 plus root 3, 1 plus root 3. Okay? 2 plus root 3, 1 plus root 3. So 2 plus root 3 into 1 plus root 3. So we have 2. So 2 multiplies everything here. So we have 2 into 1 plus root 3. Then plus root 3 multiplies everything. So we have root 3 into 1 plus root 3 again. So you then go on and have multiply 2 times 1, that's 2. 2 times root 3, that's 2 root 3. Root 3 times 1, that's simply root 3. Then root 3 times root 3, that's root 9, right? So this is 2 now, plus 2 root 3, plus root 3, plus square root of 9 is 3. So then you can collect like terms. So this is 2 plus 3. This is this 2 and this 3, plus 2 root 3 plus the coefficient of root 3 here is 1. So you have 2 plus 1 root 3 like that. So as a result of that, so you're taking this now and this. Of course, root 3 means 1 times root 3. That's why we have 2 plus 1. So we then have 5 plus 3 root 3. And that is the result we get for that. Okay, so that's how we do that. Then it's a 5 plus 3 root 3. So finally, let's talk about difference of squares identity. I mean, in many applications, we've talked about difference of two squares. It's a very fast way of handling some kind of expressions. So if you have a plus b into a minus b, that means this number here and this number here is exactly the same, except that one is plus and one is minus. And of course, if you simplify, you always get a squared minus b squared. So this identity works well with sorts too, just like it does in algebra. So imagine that you have uh, root 5 plus 2 into root 5 minus 2. That's the difference of 2 squared. That's root 5 all squared minus 2 squared. So root 5 all squared is 5 because 2, the power cancels the root. Then minus 2 raised by 2, which is 4. So the final answer is simply 1. So that's a very smart way to go about it instead of doing a lot of calculations. So just use the identity. Root 7 plus 3 into root 7 minus 3. Once you identify that the two numbers are the same, but then the signs, one sign is plus, the other is minus. Whether minus first or plus first, it doesn't matter. As far as they have the same numbers with plus minus or minus plus, you're good. So just say root 7 squared minus 3 squared. So root 7 squared is 7, 3 squared is 9. So 7 minus 9 is minus 2, for example 2. Coming for example 3, you have 5 plus root 2 into 5 minus root 2. So square root, because the 5 root 2 plus here minus here. So just the difference of 2 squared. So 5 squared minus root 2 squared. 5 squared is 25. Root 2 squared is 2. Final answer is 23 because 25 minus 2 is 23. Like that. So summary, key summary now. We have all the rules coming together. So we have all the rules coming together such that the fundamental rule is that square root of a times square root of b is square root of ab. And for mixed sorts, we have a root m into b root nb equal to ab into root m multiplied by root m times n. Then expanding brackets, you have a plus b into c plus d. You have this. And then difference of squares, a plus b into a minus b is a squared minus b squared. Nice way to go. So you have practice problems. As usual, I'll take first 10 and then take one of first 10 and then take one of last 10, 1 to 10, then 11 to 20. So 2 root 5 and 5 root 10 now. 2 root 5 times 5 root 10. Okay. 2 root 5 times 5 root 10. So again, as usual, what we do is multiply the numbers, the coefficient, that's 2 times 5, then multiply the roots. That's 5 times 10 here. So you have 2 times 5, that's 10, root 50. So from 50, we can factor out a perfect square that is not 1. That is square root of 25 times 2. Okay, so then we have 10. Square root of 25 is 5. We have root 2 there. So that is 50 root 2. And we are good to go. Okay, so Um, we can move on to other ones here. So maybe let me take the last one again. The last one is 2 root 3 plus 3. Then is there some another one I can really do? Yeah, root 21. This is just root 21. This is root 30. We cannot factor out anything. This is, of course, this is 2 root 2 times root 2. That'll be okay. I think I like that. Root 8 times root 2, right? Root 8, root 8 times root 2. Of course, that's root 16, which is simply 4. Another way to go is to say this is 8 is 2 root 2 times 2. I think this is a longer way though. So this is another way to go. So this is 2 times 2, 4 roots. This is okay, root 2 here. So this is 2 root 2 times 2, that's 4. So that again, that's 2 times 2, which is 4. So I think it's easier to, in this case now, it's easier to multiply the numbers first before you take the roots, instead of simplifying it first and then taking roots. You also want to be fast as much as possible. Okay, the last one, question 20, 2 root 3, 2 root 2 plus 3, 2 root 2 minus 3. Okay, 2 root 2, 2 root 2 plus 3 multiplied by 2 root 2 minus 3. So because this is this, but the signs are different, then you can easily do difference of two squares. So that means you have this to be equal to 2 root 2 all squared minus 3 all squared. So 2 root 2 squared means you have 4 roots 4, right? That's 2. Let me just do it methodically. That means you have 2 squared root 2 squared minus 3 squared, which is 9. So this is straight up 9. So this is 9 now. So 2 squared is 4. Then root 4 minus 9. Then this is 4 times 2 minus 9. So 4 times 2 is equal to 8 minus 9. And all of that is minus 1. So with that, we come to the end of that interesting video about multiplying surds. Okay, so don't forget to try your hands on the first 10 and of course the last 10 also. I don't think there's any other one. Okay, I think this question 15, I think it's now looking like difference of two squares. So I think I want to take that. 2 root 3 plus 1, root 3 plus 2. Okay, 2 root 3 plus 1, root 3 plus 2. 2 root 3 plus 1, root 3 plus 2. Okay, so what do? We have 2 root 3 multiplying root 3 plus 2, and then we have 1 multiplying root 3 plus 2. So that we then have 2 root 3 times root 3. That will be 2 root 9. 2 root 3 times 2, that's 4 root 3, plus 1 times root 3, that is root 3. 1 times 2, that's 2. So this is now 2 times 3. 2 root 9 is 2 times 3, plus 4 root 3, plus root 3, plus 2. So 2 times 3 is 6, plus 4 root 3, plus root 3, plus 2. So we collect like terms. So these are without radicals. So we have 6 plus 2, plus these ones are with radicals and they are like. So we have 4 plus 1. So the coefficient of root 3 here is 4. The coefficient of root 3 here is 1. So all of that into root 3. So we have 8 plus 5 root 3. That's what that will be. So finally, we come to the end of this again. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. Um, if you have subscribed already, I must thank you very much for doing that. And if you have not subscribed, the question is what exactly is delaying you? Go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join, and that gives you some special privileges like seeing some videos first and being the only one to see certain videos because you're a member of the channel. You can also request for PDF copies of some of the notes I use in teaching these things. And of course, we can also hang out to discuss whatever interests you on this channel. So it depends on your level of membership. If you want to check that out. Ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.